Dear student, today we are going to do the third application of UCM, that is Uniform Circular Motion. So earlier two application what we have seen, that the vehicle along a horizontal circle. So in that application, actually what we have seen that the first application of UCM, in that application what we have seen that the vehicle is going along the horizontal curve road. This road is actually not banked and the vehicle is going somewhat like this, okay, in this particular manner, horizontal curve road. In this particular derivation, we have found expression for Vmax. So the expression what we got, that is mu s rg, okay. But in this particular derivation, what we have seen that a force of friction, that is Fs, is important because it is trying to balance with Fcp, that is a centripetal force. That means Fs is trying to balance with the centripetal force. So the disadvantage of this application, that is of UCM, that it's totally dependent upon the force of friction. Okay. So if suppose the force of friction is going to become more, then you are not going to achieve that much of maximum velocity. So this was one of the major disadvantage of this particular first application of UCM. In the second application, what we have seen actually, second application we have seen that is nothing but that is a wall of death. That is my second application, that is wall of death. In wall of death, we found that there is one cylindrical object like this, and it was drawn like this in this particular manner. Here somewhat it was force of friction, downward it was weight, and the normal is acting towards centripetal force. So here normal is trying to balance with Fcp, okay, and the force of friction is trying to balance with the weight. Yeah. So in this case, what we found that though the object is moving along the horizontal circle, but the velocity expression what we got, that is we got v minimum, and that expression what we got, it is under root of rg upon mu s. So here there is some limitations of the speed. That means here we are going to get only the minimum speed of an object because it is moving along the cylindrical curved surface. Okay, so that's why in order to overcome these two disadvantages of these two applications, we require to do the banking of road. That is, we have to bank the road. Now, what do you mean by exactly banking of road? When we are discussing about the banking of road, so it is very much necessary that we have to understand what is actually the meaning of banking of road and why we have to do the banking of road, so that what will be the changes in the speed of an object. Okay. So the first, whenever we have to do the banking of road, suppose if we are considering that this is my road surface in this particular manner, okay, the horizontal part of the road. Now this particular part of the road, it is called to be the inner surface of the curved road, and this particular part is called to be the outer surface of the curved road. Okay, this is the inner surface and this is the outer surface, and suppose the vehicle is going in this particular manner. Okay, so now in order to bank the road, what we have to do, we have to just tilt the outer surface, or we have to lift the outer surface with respect to some angle with horizontal. So I am just trying to lift or tilt the outer surface. So the angle created is nothing but that is theta. This is actually the angle of banking. So this particular process in which we'll try to tilt or lift the outer surface of a road with respect to the horizontal, that is nothing but it is called to be the banking of road. So what is the advantage of banking of road? When we are doing the banking of road, so what we are going to find out that the car or the vehicle, it will automatically going to become like this. That means it will going to automatically tilt. Okay, like when you can see that a bike rider, when it is taking a turn along the curved surface, which is actually banked also, so automatically what will going to happen? The weight of the bike rider is actually attracted towards the center. So exactly in the case of a car also, what will going to happen? It is actually attracted towards the center. So that means there are certain forces are there which will going to balance with the centripetal force very easily in a case of a banking of road. That we're going to see with certain expressions also. So all total there are three expressions are there in banking of road. The first expression what we can see, that is nothing but that is for the safe speed. Okay, the safe speed means what? Means how much, what will be the limit of the speed when the road is banked. Okay, so for the safe speed, it is nothing but the expression is given by Vs, that is a safe speed. In a safe speed, what are the things required? You can see that in this particular diagram, which is actually here, in this diagram, you can see that here, this diagram below shows the vertical section of a vehicle going along a curved bank road having angle theta and radius r. So in this diagram I have shown that this road is banked. Okay. Now this particular part, what we are going to see here, this is nothing but this is my inner surface. This is my inner surface of the road. Okay. And what you can see here, this is nothing but this is my outer surface of the road. Outer surface of the road. So the vehicle is going like this. Okay, going along the curved surface, but which is actually bent. So this is the horizontal. This is your horizontal. Okay, horizontal line. Now this is the inner surface, and this is the outer surface. So what we have done, we have just lifted the outer surface with respect to the inner surface. Okay, or with respect to the horizontal, and we have lifted in such a manner so that it is creating some angle. This angle is nothing but, this angle is called to be the angle of banking. So this whole process in which the outer surface is lifted or it is tilted to some angle with respect to the horizontal, it is nothing but it is called to be banking of road. That is given by, angle is given by theta. So now you can see that there is one car is there which is going along the banked curved surface. Now when the car is going like this, so obviously what will going to happen? The car will be little bit tilted, and the car is tilted and it is actually directing towards the center of the road. This is the center of the road. Now first of all, we have to check which are the forces acting on the car. Okay. So when you see that, basically when we actually see that when the car is on a straight road, so here this is a straight road surface for the car. Okay, it is like this. So obviously the weight of the car, that is the weight of the car, will be downward. This weight will be downward, and the normal will be upward. In this case, in the case of a straight road. But now what has happened? You can see here. Here the situation is something different. Here you can see that a car is actually tilted because it is little bit lifted. It is because actually it is lifted. So first of all, you have to check which are the forces acting on the car. So the first force which will going to act on the car from its center, that is nothing but that the weight of the car is coming downward. It is coming downward and exactly downward, and it is given by W is equal to mg. Okay. Now here you can see that there is one more force which is acting. This force is acting. It is called to be normal. Normal means force exactly perpendicular to the surface of the object. So these two forces are acting. It is logically, it looks like this. Suppose this is a bank road and this is a car is there in this particular manner. Okay, the car. So obviously what we're going to have to locate the center. After locating the center, what we're going to find out that the weight of an object is acting downward, exactly downward, and you can see that the normal is somewhat like this. It is acting perpendicular to the surface of the car. Now when we see this, you suppose I have gone through these two forces, that is normal and weight. So in this expression, what we can find out that the weight and the normal, they are not coming in one line. Like in the case of a straight road, what we have found that if the car is like this, okay, in this particular manner, so you can see that the weight is coming downward and the normal is going upward. So here I can say that both are coming in one line. So that's why I can say the normal is trying to balance with the weight. But in this condition, when the road is banked, so normal is not trying to balance with the weight. So in this particular condition, what we have to do, we have to just resolve normal into two other components. So the two other components will be one component. It will be going towards the center. This component is nothing but it is called to be n sine theta. Whereas one component that will going to come in the line of weight, that is n cos theta. What we have here, n cos theta and mg will come in the line of n cos theta. What we have shown here, you can see that the n cos theta and weight are coming in one line. Okay, it's coming in one line, and that means what, n cos theta is trying to balance with the weight, and normal is perpendicular, and n sin theta, it is towards the center. That's why it will try to balance with the centripetal force. So by looking at the diagram, we have to first do the balancing of the equation, and then only we can find out the formula for safe speed, that is Vs. So now the diagram is in front of you. Now you can see that the diagram on the left side, right side, you can see that first balancing of the first equation, what we are going to generate, that is nothing but that is n cos theta is equal to weight. You can see that n cos theta is trying to balance with the weight because it is coming in one line. Now this is my equation number 1. Now you can see the second equation, that is n sin theta. N sin theta is coming towards the center. So when anything is coming towards the center, that means it will try to balance with the centripetal force. So I can say that n sin theta, it is equal to what? Centripetal force, we know that it is given by mv square upon r. So this is my equation number 2. Okay. When we divide equation 2 by 1, on dividing equation 2 by 1, so divide 2 by 1. Okay. On dividing it, what are we going to get? We are going to get mv square upon r divided by mg is equal to n sin theta upon n cos theta. Okay, dividing equation 2 by 1. Just I have taken this part to this particular right hand side to left hand side and left hand side to right hand side. This is a general mathematics. You have to understand this. Okay. So what we have done, we have divided equation 2 by 1. Okay. After dividing it, equation 2 by 1, I will just try to cancel mass from both the sides. That is division. Okay. So on the left side, I am going to get v square upon rg, and on the right side, I will going to get sin theta upon cos theta is nothing but it is tan theta. Okay. So here the expression of v square is equal to what? Rg tan theta. Therefore, I can write down, therefore v is equal to under root of Rg tan theta. So this is the expression for the safe speed, that is Vs, what we are supposed to get, that is Vs. In a case when the road is bent, okay, there are two more expressions are there where we are going to find out V minimum and V maximum for banking of road by introducing the force of friction. Now by looking at this particular expression, that is Vs is equal to under root of Rg tan theta, we can even find out the expression for angle of banking. We can even find out the expression for angle of banking. So I think so you have understood this concept, that from the diagram itself we have balanced, we have done the balancing of the force. Now you can see that and cos theta is trying to balance with weight, and sin theta, it is towards the center, it is trying to balance with the centripetal force. Centripetal force is given by mv square upon r. So this is my equation number 2 and this is my equation number 1. Dividing 2 by 1, on dividing 2 by 1, just I have shifted this left to right and right to left. So mv square upon r divided by mg is equal to n sin theta upon n cos theta. Is going to get cancelled. V square upon rg is equal to tan theta. Therefore V square is equal to rg tan theta, and the expression of safe speed is given by Vs is equal to under root of rg tan theta. And with this particular expression, we can also find out the formula for angle of banking. The formula for angle of banking, since we have Vs is equal to under root of Rg tan theta. Okay, that means for angle of banking, just square both the side, squaring both the side, V square upon V square is equal to Rg tan theta. I will take tan theta on the left side and everything will go on the right side. So therefore tan theta is equal to V square upon Rg. Therefore theta is equal to tan inverse V square upon Rg. So this is the expression for angle of banking. The next other two expression we will going to learn in my next lecture. Thank you very much.